going to be talking about triangles. The triangle guts, or the insides of triangles. Those are called medians, altitudes, perpendicular bisectors, and angle bisectors. First, a quick review of parallel lines. When you're dealing with parallel lines, you want to look for these three congruent angles. Draw a set of parallel lines at the top. And a transversal. When lines are parallel, these three angles are congruent. The first one, and most important, are alternate in. Opposite sides of the stir stick, but between the lines. Those are congruent. Alternate interior angles. Next one. Alternate exterior angles, opposite sides of the stir stick, outside of the lines. And the last, one's in, one's out, same side. Those are called corresponding. In all three circumstances, those angles are congruent. So let's figure out in these what we are given. First off, physically sweep the angles. I'm going to darken my stir stick. I see my two angles are opposite sides of the stir stick, outside of the lines, therefore, they are congruent. They are alternate exterior angles, so they are equal. So we have 7x equals 6x plus 10. Minus 6x both sides. X must equal 10. Let's plug in that 10 where it belongs. 7 times 10, that makes this 70 degrees. 6 times 10 plus 10, also 70. What else do we know to be true? We have a bow tie angle here, vertical angle, so that's 70. Armpits of the Z, 70 degrees. We also know that triangles add up to 180. So that is 180. 180 minus 70. That'll give us 110. This is 110. If that's 70, this whole angle here is also 110. And this whole angle here is also 110. And that is the only information we can find. We cannot find these right here because we are not giving any relationship, whether that's a bisector or not. So those are the angles that we can find. Taking a look at today's material, we're going to be talking about 4 different kinds of segments in a triangle. The first one is called a median. A median. A median is a segment which connects the vertex to the midpoint of the opposite side. The vertex to the midpoint of the opposite side. So we're dealing with the midpoint here. So step number 1, we want to eyeball the midpoint of this side. Put hatch marks around it. Eyeball the midpoint here, double hatch. And eyeball the midpoint here, triple hatch. Now we connect vertex to midpoint, vertex to midpoint, vertex to midpoint. These are all called medians. They connect the vertex or the corner of a triangle to the midpoint of a triangle. Where all three cross, that is called a centroid. Now I'd like you to trace from a vertex to the centroid. And then from the centroid to the midpoint. Those two segments, if you finger bracket them, you can feel it, but if this were x, this would be 2x. It's a x-2x relationship. From the vertex to the centroid is 2x. Centroid to the midpoint is x. It's an x-2x relationship. Then we have what's called an altitude. An altitude is a segment which goes from the corner to a right angle on the opposite side. Go ahead and draw. From corner, we call that a vertex, to the right angle on the opposite side. Just go straight down, make a right angle. Now do the same process with the two other sides. You're trying to make a right angle with the opposite side. These are all called altitudes. And where the altitudes cross, that is called the orthocenter. Goes from the corner to the right angle on the opposite side. That's an altitude. Number 3 is the perpendicular bisector. Perpendicular bisector is a segment which is perpendicular and bisects a side. Perpendicular and bisects a side. You are not necessarily going through the corner. Your eyeball is now on the side, not the corners. So bisect means to go through the midpoint. So step 1, eyeball the midpoints, hatch mark. So now through each of those midpoints, we're going to draw a perpendicular line, segment going through that midpoint at a right angle. Once again, your eyeball is not focused on the corner there. It's on the side. You're looking to make a right angle. Where the perpendicular bisectors cross, that's called the circumcenter. The last gut, if you will, the last inside segment is called the incenter. The incenter. And those are created by angle bisectors. So if you have an angle bisector, it's a segment which bisects corner angles, bisects corner angles. So sweep this angle, eyeball what looks like the middle of the angle. Your eyeball's not on the side, it's on the angle. And now draw an angle bisector. Don't forget the notation of the hatch marks. Sweep this angle, eyeball what looks like the center. Again, hatch marks. Sweep the angle, eyeball the center. These are called angle bisectors. And the three angle bisectors intersect at something called the in-center. So just as a quick review, we have something called the median. The median goes from the corner to a midpoint, corner to midpoint, and it intersects at a centroid. Then we have an altitude, goes from corner to a right angle, and it intersects at the orthocenter. Then we have a perpendicular bisector, which goes through the middle and makes a right angle, and they intersect at the circumcenter. The last one is the in-center, where you have angle bisectors, which bisect the angle, and the three of them cross at something called the in-center. Let's do a 3-problem application of this information. We are told that CH and EJ are both medians, which means H must be a midpoint and J must be a midpoint. Find anything and everything you can. We know that from the centroid to here, this is 2 times as from there to there. So let's look what we have here. E to L. E to L is 4x. And E to J, the whole thing, is going to be 8x minus 6. Let's first write out a relationship. First off, E to L plus L to J should equal the whole thing, which is E to J. We're already told that E to L is 4x. We're told that E to J is going to be 8x minus 6. Problem is we don't know L to J, but we know L to J is half of 4x. So half of 4x is going to be 2x. So now we can solve. We're going to collect like terms. And x is going to be equal to positive 3. So when we plug this in, let's see if it works. 4 times 3 is going to be 12. 2 times 3 is 6. 8 times 3 is going to be 24 minus 6, which is 18. Let's do a check. 12 plus 6 equals 18. Yes, that's a true statement. So in this case, x equals 6. Means x equals 3. Lj equals 6. E to L is going to equal 12. And E to J equals 18. Says in triangle UVT, draw an altitude from point V in red and a perpendicular bisector of side UV in blue. Let's do the altitude first. Altitude goes from corner to a right, R with a circle means right angle. So we're going to go corner to, from V to a right angle. That's going to be our altitude. Perpendicular bisector of UV. So the first thing I'm going to do is trace UV. I want a perpendicular bisector, so bisector means it goes through the middle, so I eyeball the middle. And then I want to draw a perpendicular bisector, so I'm going to draw something that goes through the middle, but makes a right angle. Don't forget the hatch marks. Makes a right angle. That's the perpendicular bisector. Final one, it says in triangle FGE PE, so we're going to trace PE, is an angle bisector. So we sweep and hatch marks, find all possible angles. Let's see what we're given. We're told angle 1 is 6x plus 8. We're told angle 2 is 7x plus 3. Well, with the hatch marks, we know those two angles are equal. So 7x plus 3 equals 6x plus 8. We're going to bring our x's to one side and numbers to the other. X equals 5. Now we're going to find all possible angles. So here we're going to add 7 times 5, which is 35, plus 3. That's going to be 38. And this is 38, and this is 38, which means this large angle, measure angle FEG, must therefore be equal to 38 plus 38. $76 degrees.